friends, welcome back to my channel Techno Education Academy. In this video lecture, we will discuss about the basic laws of Newton's first law, second law and third law. We will also discuss day-to-day life examples of Newton's law of motions and the concept of momentum. Newton's law of motion. In the field of physics, Newton's law of motion is a foundation of classical mechanics. It gives us an idea of how an object behaves when it stands, moves, or any force acts on it and its response. In 1687, these three laws were first compiled by Sir Isaac Newton. Basically, this law describes the relationship between the force which acts on the object or body and the motion. First law of Newton. A body continues in its state of rest or uniform motion unless compelled by an unbalanced external force to change its state. We can also write down this statement. A stationary object will remain stationary forever, and a moving object will forever move in straight line with constant momentum unless prevented from changing state by an externally applied force. Okay, this is the first law of Newton. From Newton's first law, we derive two very important concepts. The first one is inertia of matter, and the second one is the definition of force. We have already discussed in my previous lecture what is force. Force means it is an external agency due to that body is occurring a motion. Newton's first law of motion, the inertia of matter. The characteristic for which a stationary object or body wants a stationary state or a moving object to maintain its state of motion or prevent it from changing its state is called inertia. The mass of matter is the measure of inertia. There are two types of inertia. The first one is inertia of rest and the second one is inertia of the motion. Now we will discuss inertia of rest. A stationary object always remains in a stationary state. The tendency of matter to remain in a stationary state forever is called inertia of rest. So, this is the tendency of matter, okay, for the object. Okay, it will try to remain in stationary state. It is called inertia of rest. Let us try to understand the concept of inertia of rest through this animation. When a bus starts moving suddenly, the passenger sitting in the bus is thrown backward. This happens for stability. When the vehicle is stationary, at that time passenger is also stationary. All parts of the passenger body are stationary. But when the bus starts moving suddenly, the lower part of the passenger body moves with the bus because it is adjacent to the bus. But upper part of the body wants to stay still under the influence of static. So the passenger leans back. So a passenger would remain at rest, thus causing the sensation of backward acceleration. So the bus moves suddenly, the passenger jerk backward. So you can easily understand the inertia of rest through this animation. Okay. The next one is inertia of motion. It is the tendency of a moving object to move along a straight line with constant velocity is called the inertia of motion. Let us try to understand the concept of inertia of motion. When a moving car stops suddenly, okay, for example, whenever we apply the brake or any obstacle is there in front of the car or bus, okay, at that time we will stop the car or bus suddenly. So the passenger of the car leans forward. As the vehicle is in motion, the entire body of the rider is in motion with the vehicle. So as the vehicle comes to a stop, the passenger lower body comes to rest, but the upper body still leans forward to maintain momentum. So the body wants to go, as a result the passenger leans forward. Okay, so it is the example of inertia of motion. And now we will discuss the examples of Newton's law of motion in our day-to-day life. Okay, wearing a seat belt in a car while driving is an example of Newton's law of motion. It is the example of first law of motion. If an accident occurs or brakes are applied to the car suddenly, so the body will tend to continue its inertia and move forward, probably proving fatal. To prevent such accident, seat belts are used. We are using seat belt. So stopping your body from moving forward in inertia and avoiding any accident occurs. Okay, so this is the example of first law of Newton. Now we will show some more example of Newton first law of motion in our day-to-day life. When the bicycle stops suddenly due to any obstacle in front of it, so the rider will get a jerk in forward direction due to the inertia of motion as the bicycle is stopped. The body in contact with the bicycle will also try to stop, but the upper portion of the body will still try to maintain its motion. Okay, so it is the example of first law of motion, okay, in our day-to-day life. The next example, here you can see that if an index card is placed on top surface of a glass with a coin on the surface of the index card, so the index card can be quickly removed while the coin falls straight into the glass. Okay, as the coin is demonstrating the inertia at rest. So here you can see that, okay, the coin which is put on the surface of the index card, okay, it is already in rest position. Okay, and here we applied the force on the index card. So index card, it is in motion, but coin is already in static condition. Okay, so it will demonstrate the condition of inertia of rest. So the index card can be quickly removed while the coin falls straight into the glass because it is in rest position, and the index card, it is in motion. So it will demonstrate the concept of inertia at rest. Next one, here you can see that if you jump from a car or a bus that is moving, okay, that is already in motion, so your body is still moving in the direction of the vehicle. When your feet hit the grounds act on your feet and they stop moving. You will fall because the upper part of the body did not stop, and you will fall down in the direction of the motion you were moving. Now we will discuss about Newton's second law. According to the statement of Newton's second law, the rate of change of momentum of a body is directly proportional to the applied force and take place in the direction of a force. Newton's second law explains the concept of momentum, the measure of force, the unit of force, and the neutral principle of force. First of all, what is momentum? Momentum means mass into velocity. So the amount of motion created by the combination of mass and velocity in a moving object is called momentum of the object. The value of momentum of an object is equal to the product of object mass and its velocity. We have already discussed momentum means mass into velocity. Let us assume an object having mass m moving with a velocity v1, its initial velocity is v1, and applied force is F on the object for time t. Now the form acceleration in the object is a and the final velocity is v2. So initial momentum means mass into velocity. So the initial momentum is m1 into v1, and after the time t, momentum is, or we can say final momentum, or we can say final momentum m2 into v2. So change in momentum, here the mass remain constant, so it is keep it outside. So change in momentum equal to mass in bracket final velocity minus initial velocity. So according to the second law of Newton, the rate of change of momentum, okay, with respect to time, okay, rate means with respect to time, change means difference. So here we are considering difference, final momentum minus initial momentum divided by time. Okay, so the rate of change of momentum equal to m2 v2 minus m1 v1 divided by t. Here mass is constant, so it is keep it outside. So change in velocity divided by time. But we know that rate of change of velocity, it is called acceleration. Okay, so dv by dt, or we can say v2 by v1 by t equal to acceleration. Okay, the unit of velocity is meter per second and the unit of acceleration is meter per second square. Okay, so meter per second divided by time. So meter per second divided by time means meter per second square. So it's acceleration. Okay, so put the value. So here we can prove that, or we will derive the equation of force F equal to ma. The unit of momentum in SI unit kg into meter per second. What are the application of Newton's second law? Newton's second law is applied to identify the amount of force needed to make an object move or make it stop. Following are the few examples that we have listed to help you understand this point. Whenever we kick a ball, we exert a force in a specific direction. The stronger the ball we kick, the stronger the force we put on it and the further away it will travel. So the acceleration of the ball, it will depend on how much amount of force we applied. Okay, and it will also depend on mass. So the force we applied, it will depend on mass and acceleration of the object. The second example, we are considering pushing a cart. Okay, it is easier to push an empty cart in a supermarket than a loaded one, and more mass required more acceleration. The another example, two people walking on the road. Okay, so here we are considering two people. One is lightweight and another is heavyweight. So among the two people walking, if one is heavier than the other, the one heavier weight person will walk slower because the acceleration of the person weighting lighter is greater. So we know that F equal to ma. Okay, so whenever the mass of the object is less, so its acceleration is more. Now we will solve the examples of Newton's second law. Then after we will discuss third law of Newton and its real life example. There is a block of mass 2 kg and a force of 20 Newton is acting on it in the positive x direction and a force of 30 Newton in the negative x direction. Then what would be its acceleration? Okay, so as per the schematic diagram, here you can see that, okay, the mass of the block is 2 kg and the force 20 Newton, it is acting in positive x direction, and the force 30 Newton, it is act in negative x direction, and our objective is to calculate its acceleration. So we know that F equal to ma. We have already proved that according to the second law of Newton, the rate of change of momentum is directly proportional to force. So net force, okay, 20 Newton minus 30 Newton, we know that, okay, 20 Newton, it is in positive x direction and 30 Newton, it is in negative x direction. So 20 Newton minus 30 Newton. So the net force is minus 10 Newton. Here the mass is already given 2 kg. So here we make the object acceleration from this equation. So acceleration equal to F divided by m. F means net force and m means mass. So here net force we have already calculated, minus 10 Newton, and mass is given 2 kg. So acceleration equal to minus 5 meter per second square. So the negative acceleration indicate that the block is slowing and its acceleration vector is moving in opposite direction, directed opposite to the direction of motion. Now we will discuss Newton's third law. To every action there is an equal and opposite reaction. Let us try to understand the Newton's third law with some real life example. When a gun is fired, the gun exerts the force on the bullet. This force causes the bullet to accelerate forward. Bullet also exerts an equal and opposite reaction force on the gun. As a result, the gun moves backward. So the person who fires the gun feels shock. Okay. So it is the example of Newton's third law. To every action there is equal and opposite reaction. The another example we will discuss. When a rider jumps from a boat to the shore, So the boat moves backward. When launching from the boat, the rider exerts a force on the boat. As a result, the boat moves backward. Immediately, the boat exerts an equal and opposite reaction force on the rider, causing the rider to reach the shore. This is the example of Newton's third law. The another real life example of action and reaction involving aerodynamics. So the motion of aircraft engine produces a thrust, and the hot exhaust gases flows out the back of the engine, and a thrusting force is produced in the opposite direction. Okay. Another example, you can consider the example of air-filled balloon. Okay, whenever it is exposed in the atmosphere, so it will move upward because it will exert an equal and opposite force in downward direction, so it will move upward. This law can be observed anywhere and everywhere in the surrounding. Some examples of the action-reaction pair are mentioned below. A swimmer pushes the water backward with their hands, and in return, the water pushes the swimmer forward, thus enabling him to go forward during swimming. So this is the real life example of Newton's third law. A man walking on the ground. While walking, a person pushes the ground in the backward direction, and the ground in the return pushes the person in the forward direction, thus making them walk. Okay, so here you can see that the action reaction force, okay, on the ground whenever we are walking on the surface of road. So this is the another example of Newton's third law. The next example, a bird while flying pushes the air downward with the help of its wing. Consistent with Newton's third law of motion, the air makes the bird go upward. So there are lots of examples of Newton's third law of motion in our day-to-day life or in environment. If you observe it closely, you can find it anywhere and everywhere. So thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends, and also press bell icon for more video notification.